Let's do molecules with more than one chiral center in Fisher projections. So now I'm going to draw, say that I'm going to keep doing my, say, polyhydroxyaldehydes or ketones. So I'm going to say that's the condensed way to write an aldehyde formula, and I'm going to write here HO8, and that will be a molecule with two chiral centers, 1, 2 here. So now this molecule, if I draw, say, imagine that I have a mirror here, we will draw the enantiomer to the molecule the following way. We will have OH, H, OH, H, and here CH2, OH. And so the relationship then between these two molecules is enantiomers. And now if I draw, I'm going to draw something different. Say that I have now CHO, and let's look at relative to that. I'm going to do HOH. So I'm going to keep that first carbon chiral center the same, but now I'm going to change this one and CH2OH. Now this is no longer, see this two, they're not mirror image. So the relationship between these two molecules, so they have, again, isomers, but what type of isomers? Stereoisomers. What type of stereoisomers? Not mirror image, they are diastereomers. Now we're going to do here, learn how to determine the absolute configuration when we have molecules drawn that way. And here we need to remember that what we said about the convention in Fisher. So I'm going to draw it small here. Say that I have dash, 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 so whatever was vertical. And the horizontal, we're going to have the wedges. Right. So now if you had, and let's draw a small example. Say that I have a hydrogen here. Oh, I need to draw it lower. It's not showing on the screen. Okay, I'm going to draw here, hydrogen. This is a small example. And I need to draw a chiral center. This color is not showing much. So I'm going to just draw on top of that. I mean, this is an H. And here I'm going to draw an OH. And here in the wedge, I'm going to say that's a chlorine, and this is a metal. So now, remember that when we did absolute configuration, the first thing was assigning priorities to the different functional groups attached to the chiral center. So here we see that the highest priority will be chlorine, because it's the highest atomic number. Then next will be this hydroxide, so the oxygen. Then we have the metal, because it is attached, the carbon is what's directly attached to the chiral center. And lastly, the hydrogen. So that's what we have. What is the absolute configuration of this molecule? The other point that we need to make sure is how we are looking at the molecule. And the lowest priority group needs to be away from your view. Actually, in that drawing, hydrogen is pointing inwards, isn't a dash. So I'm looking at that the correct way. And all I need to do is follow the sequence. So 1, 2, and 3. So this center is R. Now, the way that I have drawn the molecules here is not that, actually. We notice that the hydrogen is not on a vertical line. So it would be in one of the horizontal lines. And so I'm not looking at that the right way. So let's assign first priorities. So the first step, assigning priorities. Then we look at if the lowest priority group is away from our view. And if it's not, we need to do a few things. So either we do a switch or we rotate. Let's see what's practical here. So Now, in this molecule, let's say that I'm talking about the chiral center above. So highest priority, notice, is these oxygen here. They might between this is tetran and that's tetran. Here, carbon and another carbon. But to assign better priorities, I'm going to redraw the aldehyde functional group so that we see clearly how many bonds to oxygen do we have. So in that case, now I see here carbon in carbon. Now this carbon is attached to, we count twice, oxygen, oxygen, hydrogen. So I'm going to say OOH. And what is attached to this carbon now is one O into H's. So the group above has higher priority. So I'm going to say this is priority 2. That chain, and again, we are doing the configuration at this chiral center. So third priority is a chain below, and number 4 is a hydrogen. But now I know my convention is that, in that my hydrogen is actually not like in this one, pointing inwards, but actually the opposite. So here we can do physically one switch and put it here. Or we can do it mentally. So let's imagine we're going to do the switch, the configuration as is, and then we're going to think that we have inverted this two. If we do it like that, we'll say 1, 2, and 3. But I'm looking at that with the hydrogen pointing towards me, should look like counterclockwise in S, but really the hydrogen is pointing towards me, so the configuration will be R. Again, I'm doing that because the hydrogen is pointing towards me. And if I do now the configuration at the other carbon, see at the enantiomer. Looking at that, I already assigned priorities, so we said 1, 2, and 3, the chain below, and this is 4. And then I go 1, 2, and 3, looks like R, but the hydrogen is on a wedge. Again, it's in a horizontal line. So it will be S. And notice that the configuration at the chiral center is inverted, and that should be the case. Always in the enantiomers, the configurations are inverted, but it should be the case for the 2 carbon, for the 2 chiral centers. So let's do the one below. And for that, let's assign quickly priorities 1. And then I'm going to say this carbon is attached to oxygen, hydrogen, hydrogen. And this one here, and this will be carbon above attached to oxygen, carbon. So this has higher priority, the chain above. So I'm erasing those numbers that I did previously because now I'm doing the configuration of this chiral center. So again, priority 1 is this. In priority 2, notice this is oxygen, hydrogen, hydrogen. The carbon here at the other chain, let's do that. That's going to be oxygen, carbon, hydrogen. So this chain has higher priority, so say 2 is above, and then 3, and that's 4, and I will go 1, 2, and 3. But it's looking like S, but I'm looking at that the wrong way, so it is R. And looking at the priorities, here it should be the same priorities because they're the same group. But now here I'll say again 1, and then 2 will be above, the chain above. 3 is this one, this is 4. And now I'm going to go 1, 2, and 3. Look like clockwise, but it's S. So what I want you to see here is that the configuration of the chiral centers, the 2 are inverted, and that's the case for enantiomers. So we're going to continue doing more of that. I'm going to do another video doing the configuration of the other molecule.